our final, that will be focus of the day 10, the engineering manager role. But before we move there, we have to concentrate on software database architect. So what we learned till now is about the background in terms of the decision making. We learned to build Spring Boot REST, actuator swaggers. We learned to build the infrastructure. We learned to build business microservice and use them. Okay. Now all this is fine. Now this was up to the point that we are kind of having good understanding. We understand terms when somebody tells us what is ribbon, what is fan, when somebody tells us why so many components. We understand the pain points that we need to build so many things, and then we build a focus on business use cases. We understand the advantage of that. Yeah, but then where is our main thing? I mean, beyond all of this, we had a main point, right? In terms of all this started because of one of the primary problems, just database. So in what we discussed on day 1 and day 2, we will today talk about it up to one. I mean, up to a point where you can at least start understanding, visualizing the all the data management patterns that are there, and then you decide for yourself based on the problem that you're facing. Okay. Now, whatever I take in this particular session, it will not be like everything. Like this is a very big topic. There'll be Udemy courses. There'll be some possibly certifications. There'll be institutes taking only course which is data management patterns software architecture. It's a very extensive topic. Okay, each of these things. Okay, people might be taking topics which are testing for microservices, simply microservice developer, the idea of DevOps in microservices, engineering managing microservice projects, and data management is one of the important topics. So all of this might be one course by itself, one important, possibly spanning 10 days, 5 days, 6 days by itself. Okay, so we give you starting points. I'll give you starting points to the best of my within the time constraints. Okay, and whatever we can do best. Your effort has to continue. Each of your person's effort has to continue for your project, for individual that you are, so that you can take your project and your organization ahead. So what are the most important data management patterns? Okay, so when we had monolithic architecture, so let's go back to our day 1, 2. When we had monolithic architecture, prior to that, in terms of understanding of this course, we used to have problems. I mean, in monolithic architecture, we used to have problems where the most important contention point was database. We have one database, everybody talking to the same database, and we suffer from things like symmetric scalability. I hope you remember that term. And in real world, organizations and projects, they require asymmetric scalability. So let's think of a scenario where you have inventory service, the GIMS, SACS GIMS inventory service, and you have your ordering service, okay, and possibly you have a payment gateway. So this example we have been taking right from beginning. So there, we know right from beginning that if you have to use one database for all, okay, we use one database for all in a monolithic architecture. So we are going to face an important point of contention, which is performance. Now, you come back, you move ahead in the world of microservices because now you have understanding. If you have to move ahead in the world of microservices, okay, you are going to we need to before we come to this even before we come into this slide, there is something that you need to visualize when you think of microservices. Now we divided the problem of order service, payment gateway, inventory service into three different microservices. Okay. Now, what was the yardstick of selecting these microservices? We had gone to the entire detailing, right? What are the ways? What are the reasons why we make something microservice? There's so many things like this is the core features, stability. There's core features, scalability, and then there might be things like what do you say? Independent development. Okay, technology affinity in a geography. So all those things we have gone through quite intensively, and we covered that whole topic. Like I think we covered the extent of the topic. So when we go through that, what are the reasons? Okay, it is not database, even though it's a primary concern, it is not the only concern, right? sometimes we might have applications, they don't have database at all, right? Maybe you built in your experience or not built using in your experience. There might be systems which are very heavily intensive on logic. They require CPU power, they require RAM, they might require file system, but they don't require RDBMS or they don't require NoSQL. Or for that matter, they don't require file system also. They are very highly intensive on computation. They might be intensive in on CPU, on RAM, uh, possibly, I'm not sure, maybe some graphics drivers or whatever, like in your system, all the resources which are there, the clock speed as well. I mean, CPU speed, not just the number of processors, but the CPU speed. So it might be very logic intensive, like scientific computations, right? Maybe related to space science or even in normal, possibly in applications of e-commerce, there might be heavy data analysis running there. Okay, it might be of the nature of possibly some processing which is of big data kind of nature, where it's requires intensive computations. So under such circumstances, what is going to happen is that the CPU, the actual physical server, is also a contention, right? So I cannot unending ways, I cannot give the number of servers. I can, obviously, depending on my business, depending on my needs of application, because maintenance is also one problem. So when we are talking of when you come to this topic, it should not be, it should remain in your mind that database is not the just the only problem. Okay, so also issues might be in terms of resources that we need from any system. They can all be bottlenecks for the they can all become bottlenecks for the microservices architecture. For the software architecture, because of which we require microservices. So with that understanding, let's move to the first design pattern. Okay, uh, which is database for service. Okay, so okay, so here the diagram which they have shown. In this, there's order microservice and customer microservice. So when we are going to work with dedicated database, okay. So if this order and customer were together, if they are together into one model, if they're talking to the same database, okay, database means physical database server. We could have clustered it, we could try to scale it, but then what we realized, using all the knowledge that we have from 9 days, we need to split into microservice, okay. Because order microservice makes lot of invocations to database, and customer microservice also makes a lot of invocations. There are many CRUD operations, and they both, because of those reasons, they merit different dedicated database per service. Okay, so as the name suggests, it's a database per service. Okay, so what do you decide as the decision maker, as a developer, architect, engineer, manager, whatever role? I mean, in collective decision making, you decide that I'm going to split this into two different microservices and have a dedicated database per service, which means all the order managements or order microservices, tables, okay, procedures, everything is going to go into the order database, and everything that belongs to, let's say, customer schema, and the stored procedures or anything, any database requirements are all going to go to the customer database for customer microservice. Now, up to that point, it's fine. Okay. So what are the issues that we're going to face? You have to just you have to tell me. Okay, be with me, and now you recollect from your 9 days and tell me what are the issues that you're going to face. Let's say the center part is not there. The center part which says messaging, consumer, publisher. So you tell me what is going to happen. We solved the problem. We built a microservice, and we built a database per service, and the customer microservice we built, and we added customer database. Now, what is going to be the problem? We have answered this earlier also in our earlier sessions, but here, because we are coming to the actual design pattern or data management pattern. So if the center part is not there, which is saying that consumer, publisher, messaging, what is going to happen? So this is the most important problem that is faced when you build microservices. I want to hear from you guys.
DSA issues.
Yes, number one. Yeah. Same thing. Variants of data sync issues, right?
Yeah.
Means that wrong data shown to the customer. We may be doing some wrong computation at the back end. Okay. And it might happen that never there's no consistency in what you're showing and what is being updated by customer. Okay. That's the same thing as the first one. The first thing is what is being shown to the customer and what is happening at the back end, like in terms of actually processing some critical business use case, something absolutely wrong data that we are having, right? So that is where the central part comes in, the consumer, publisher, and the messaging. So once we have database per service, we know syncing